Kia ora everyone. This is almost everything you'll need to know about the bones of the foot. We'll start with a superior view here. This is the calcaneus or heel bone, and it extends out underneath this other bone, which is the talus, which is the key bone in the foot. The talus articulates distally here with the navicular, a boat-shaped bone. The calcaneus articulates distally with the cuboid. These three bones here are collectively known as the cuneiform bones. They are wedge-shaped in section, which is what cuneiform means. And there's a medial, an intermediate, and a lateral cuneiform bone. All together, those bones make up the tarsus. They are the tarsal bones. These long bones, more distal to them, are the metatarsals. There are 5 of them. As long bones, they each have a shaft, a base at the proximal end, a neck, and a head at the distal end. The metatarsals articulate distally with the phalanges, and they too are long bones with shafts, bases, necks, and heads. There are 2 phalanges for the big toe, the hallux, and all the others have 3. The talus and the calcaneus together form the hind foot. The rest of the tarsals comprise the midfoot, and the phalanges and metatarsals together form the forefoot. Some of the important joints in the foot are the subtalar joint, which is the joint between the calcaneus below and the talus above, and we'll see more of that joint later. This is the calcaneo-cuboid joint, and that is alongside the talonavicular joint, and together these form a compound joint, which is the transverse tarsal joint. Other intertarsal joints are less distinguished, so we won't bother with their names. Distal to those we have the tarso-metatarsal joints, more distally the metatarso-phalangeal joints, and then the interphalangeal joints. The big toe, again, has only one interphalangeal joint because it only has 2 phalanges. The other toes each have a proximal interphalangeal joint and a distal interphalangeal joint. Looking at features of the individual bones, the calcaneus posteriorly and inferiorly has this bulbous extension, which is the tuberosity of the calcaneus, and it features medial and lateral processes, which we'll see better in another view. The calcaneus has an anterior process here, the most superior and anterior part of the calcaneus, and laterally it has a small spur of bone, which is the fibular trochlea. That acts as a pulley to redirect the tendons of fibularis longus and brevis after they've descended vertically down from the leg. They pass the fibular trochlea and are redirected anteriorly in the foot. So the groove behind the fibular trochlea is the groove for fibularis brevis tendon, which is the deeper of the 2. The talus is a large bone. It has a body here, and a neck here, and a head here, which is the part that articulates with the navicular. It's a very rounded head and forms essentially a ball and socket joint with the navicular and surrounding ligamentous structures. Posteriorly, the talus has a posterior process, which also has a groove in it, and that's the groove for the flexor hallucis longus tendon. Either side of the groove are tubercles, a medial tubercle here and a lateral tubercle here. The navicular bone has a tuberosity here medially, and the 5th metatarsal has a tuberosity at its base laterally. The 1st metatarsal also has a tuberosity at its base. We'll change views to a medial view, and we can see here the tuberosity of the calcaneus with its lateral and medial processes. We'll see them better still later. This shelf of bone that projects medially is the sustentaculum tali, which is a shelf of bone that helps support the more medially lying part of the talus. Sustentaculum essentially sustaining that part of the talus. And we can see here the subtalar joint. We can see the lateral and medial tubercles of the talus with the groove for the flexor hallucis longus tendon in between them, and that tendon is redirected anteriorly and passes underneath the sustentaculum tali, and there's a groove in the inferior surface of the sustentaculum tali also for the tendon of flexor hallucis longus. We can see in the body of the talus here the superior articular surface, which is the trochlear surface. Trochlear because it's grooved or spool shaped. Trochlear in anatomy has two meanings. One is it looks like a spool in cross section, so the trochlear of the humerus is another trochlear. The other meaning is to act functionally as a pulley and redirect the course of a tendon. So the fibular trochlear on the lateral side of the calcaneus does that, as does the trochlear in the orbit, redirects the tendon of superior oblique. Functionally, we can see in this view that the weight of the body is transmitted entirely to the talus here, and the weight is distributed by the talus posteriorly to the calcaneus via the subtalar joint, and the rest of the weight is distributed anteriorly along the medial section here, and some also along the lateral part of the foot. Weight is borne along the metatarsophalangeal area, and the bony and ligamentous structures that transmit the weight form arches. So there's a medial longitudinal arch along the medial aspect of the foot, and a shallower lateral longitudinal arch. And the arch is so shallow that the lateral part of the foot does also contact the ground, whereas the medial part of the foot is held away from the ground, but is more important in movement rather than stance. So the medial longitudinal arch becomes active in push-off when mobilizing. In between the two arches in the midfoot is the transverse arch here. And all these arches together give a mechanically superior weight-bearing facility to the foot, much more so than would simply flat weight-bearing surfaces. We'll move now to a lateral view, and we can see now the lateral process and the medial process of the calcaneal tuberosity, the fibular trochlear, the anterior process here, and the lateral part of the subtalar joint. This area here, which you can look into, is between the talus and the calcaneus, is the tarsal sinus. It's a cave. In life it's filled with ligament, which is the interosseous talocalcaneal ligament, which is a very strong ligament that helps strengthen the subtalar joint, such that the subtalar joint is incredibly strong and is hardly ever able to be disrupted. We can see the talonavicular and calcaneocuboid joints here alongside each other, together comprising the transverse tarsal joint, and we can also see the external dorsal surface of the transverse arch of the midfoot. And we can move on to the final view, which is an inferior view. Again, the prominent medial and lateral processes of the calcaneal tuberosity. This bar of bone here doesn't seem to have a name. We can see the very large shelf-like projection of the sustentaculum tali here, supporting the talus above it, the tuberosity of the navicular here and of the base of the fifth metatarsal here. Inferiorly on the cuboid bone there is also a tuberosity, this structure here. Distal to it is a very prominent groove, and that's the groove for the tendon of fibularis longus, which has passed inferiorly from the leg, is redirected anteriorly in the foot, and then crosses all the way underneath the foot, partially in this groove in the cuboid bone, to reach the medial side of the foot and is attached to the medial cuneiform bone and the base of the first metatarsal. And it acts as a stirrup to again help sustain the arches, particularly the transverse arch, which it courses immediately beneath. Another key feature in the maintenance of the transverse arch is the fact that the cuneiform bones are so wedge-shaped, so they were quite large bones superiorly, but you can see that they've tapered to narrow surfaces inferiorly, and it's this wedge shape that helps form the arch, much in the way that wedge-shaped stones form the apex of the arch of a bridge. Very interestingly, we see here that the inferior part of the head of the talus is exposed in a dry bone, in a dry skeleton. In life, this part of the foot is covered by the plantar calcaneonavicular ligament, which extends from the sustentaculum tali of the calcaneus across to the inferior surface of the navicular and covers the head of the talus and acts as a hammock or nest for the head of the talus. The plantar calcaneonavicular ligament is also called the spring ligament because it adds a dynamic facility to the medial longitudinal arch in this way, as opposed to the calcaneus, which is essentially a block of bone which helps form the lateral longitudinal arch. The medial longitudinal arch, because particularly of this ligament, is slightly more dynamic and springy and is able to contribute to movement more effectively, much in the same way as this guy's feet are more springy and dynamic and enables him to run better than this guy's feet, which are less so. Another important ligament is the calcaneocuboid or short plantar ligament, which extends from the most distal part of the inferior surface of the calcaneus across to the cuboid bone, proximal to the tuberosity. Actually, I'll do it in this color here. If we redraw the tendon of fibularis longus, there is a more superficial, long plantar ligament, which is also a calcaneocuboid ligament, which extends from this bar of bone more proximally across the tuberosity and across the tendon of fibularis longus to the more distal part of the cuboid bone, and also extends onto the lateral three bases of the metatarsals, forming a bridge over the tendon of fibularis longus. And this is the long plantar ligament, which is also the calcaneocuboid ligament, but is more superficial than the short plantar ligament. I dedicate this view to my kids, who are all juvenile males, who have been big supporters of the channel. Considering the subtalar joint, if we look at this view of the isolated calcaneus from above, these are the articular surfaces that support the talus. The main one is this posterior surface, or posterior facet. This facet on the superior surface of the sustentaculum tali is the middle facet, or middle articular surface, and this smaller area here near the anterior process is for the head of the talus, and it's the anterior facet. And when we consider the matching surfaces of the talus, this large surface here will be for the posterior facet on the calcaneus. This medial surface here is for the area on the sustentaculum talus, the middle facet, and this area here will be for the anterior facet. And then if we put them together, the point of this is that anatomically, this area here is a separate joint. You can see that it's separated by the interosseous talocalcaneal ligaments. It's a separate synovial cavity, and this is the true anatomical subtalar joint. These other areas, from the middle and anterior facets, are also subtalar in that they are between the talus and the calcaneus, but because they're in a separate joint cavity along with the talonavicular joint, anatomists call this the talocalcaneonavicular joint, or TCN joint. Clinicians consider the functional subtalar joint as being the anatomical subtalar joint plus the talocalcaneal parts of the talocalcaneonavicular joint. So the articular surfaces shown here in pink and blue. So all three articular surfaces are considered functionally to be the subtalar joint, and the other part, the talonavicular part of the TCN joint, is a separate functional joint. Functionally, inversion occurs across the axis of this combined, so it's a rotational movement around this oblique axis of the foot, inversion, eversion. We'll just look quickly at this view, which emphasizes how particularly the middle cuneiform here helps form the transverse arch. It acts as a keystone at the apex of the arch. And lastly, we'll look at some x-rays. AP view here, we can see the body, neck and head of the talus and its articulation with the navicular bone here. And we can also see the calcaneocuboid joint alongside it. In this view, we see the medial and intermediate cuneiforms articulating with their metatarsals in the medial two rays of the foot. The other tarso-metatarsal articulations are obscure because they tend to overlap, which is why we always get an oblique view in x-rays of the foot. So in this view, the tarso-metatarsal articulations of the lateral rays are clearly seen, whereas the first two rays are now overlapping. Again, we can see the calcaneocuboid joint and the talonavicular joint, and this is showing us a very nice view of the tarsal sinus and relative paucity of bone here because it's a hollow cave filled with ligament. We can see the posterior facet of the subtalar joint and the tuberosity of the calcaneus. Finally, we have a lateral view, and here again we see the tuberosity of the calcaneus and the sustentaculum tali projecting out towards us or away from us, we can't tell. We can see the middle facet here though of the subtalar joint, and especially if I remove the orange lines, we get an idea of the trochlear surface of the body of the talus. Again, the tarsal sinus is relatively radiolucent area, and the very nice head and neck of the talus, the talonavicular joint. We can also see the anterior process of the calcaneus here. This is the tuberosity of the cuboid and this of the fifth metatarsal. We could draw in the plantar calcaneonavicular ligament from the sustentaculum talus here to the inferior surface of the navicular, the spring ligament. And we could also draw in the short plantar ligament from the inferior surface of the calcaneus to proximal to the tuberosity of the cuboid, and the long plantar ligament which would bridge that structure. We could imagine that the tendon of fibularis longus is just here, covered by a long plantar ligament which extends onto the bases of the metatarsals. And along with the tendon of flexor hallucis longus and other long tendons, these all contribute to maintenance of those very important arches of the foot. That's almost everything you need to know about the foot. It's a fairly exhaustive review. Anyway, I hope you found that useful. Next time we'll move on to the muscular compartments of the lower limbs. Until then, ka kite.